AB Calculus Note Card 54, Properties of Integrals. This is the 54th video lesson in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District. Here with lesson 54, we're building upon what we looked at in lesson 53, which was anti-differentiation. And just to bring a little context here, properties of integrals. What you have in an integral is this. You have this thing which is the integral symbol, and it's really a command. And that command is to integrate what follows, or anti-differentiate. And then what you have after that, in this case 0 dx, this is called the integrand. And if, as is the case in all of these integrals here, with no numbers at the bottom or at the top of the integral symbol, this is called an indefinite integral, meaning that the answer is going to include, as part of it, the constant of integration, c. Okay. Constant of integration. And so these are the rules. If you have the integral of 0 dx is c. If you have the integral of dx with a constant k out front, in fact, one thing you can do when you have a constant, you can move that constant out in front of the integral symbol, and you have just kx plus c, and then you have different ways of notating here. In fact, that's what they do in this number 3. They take this k, move it out front. Okay, that's what happens there. And the biggest thing we're going to be looking at that's going to be used most often is what's called the power rule of integration, and this is it right here. And what this is going to do is better articulate what we started to introduce in note card lesson 53, the anti-differentiation. So there's a rule for this called the power rule, which I hope is going to make sense. And then if you have an integral that is a sum or a difference of two terms, as in this case, you can break up these terms into two separate integrals. So that's plus or minus. So we're going to go over some problems. Now we're going to integrate all these, and again, this symbol here is a command. It says integrate what follows. In order to integrate, you need to have some kind of a function, and then you're going to have normally a dx or a dt or something. Here you want a dx because that matches the variable in the function here. And before we actually solve this, I want to go into a little background. Let's assume we have a function that we know is a derivative. Let's say we have y prime equals -6 x cubed, and we want to go ahead and solve for y. Well, I'm going to rewrite this y prime as dy dx. So you have dy dx equals -6 x cubed, and then to solve this in terms of dy, if we cross multiply the dx, we have dy is equal to -6 x cubed dx. And now with this in place, we can integrate both sides of the equation. On the left side, we're going to have y, and y is going to be equal to, we'll have -6x, actually -6, the integral of x cubed dx. And now we're going to use the power rule. Going back here, the power rule is that we take our variable to a power and raise that power by 1. So going back here to problem 1, we're going to have y equals -6, and we're going to have x, and that's going to be x3 plus 1, n plus 1, so that'll be 4, and then we're going to divide by 4, and the moment we integrate on one side, we have a constant of integration plus c, and really when we integrated this y on the left side, we had a c at that point too, and then the only thing we can do from here is we could say y equals a -3/2 x to the 4th power plus c. So that'll be our answer. And of course, in this instance, we didn't start out with y equals, but I wanted to back off and show sort of a context in how an integration will be used to create an equation that is the differentiation of an initial function. Okay. On these subsequent ones, I'm not going to do as much explanation. Well, here we have number 2, the integral of quantity x squared minus 10x to the 4th power dx. And for that, we're going to go back here and look at rule number 5, and also in combination with the other things. So we're going to separate this into 2 separate integrals. We're going to have x squared dx minus 10, I'll put this minus 10 x to the 4th dx. So we split this integral, the 2 terms of the integral. Next, I'm going to rewrite this, I'm going to continue to write this as x squared dx. And now with this -10, I'm going to pull this 10 out front. So I have minus 10 x to the 4th dx. And now we're going to apply the power rule here. And the moment we apply that power rule and remove these integral symbols, we're going to have at the end of our answer a plus c. So that's going to be a given. So we're going to have x to the 2 plus 1, which is 3, divided by 3. And then we're going to have minus 10. We're going to have x to the, what is 4 plus 1, x to the 5th, divided by what we raised to, which is 5. And then we have plus c. And finally, as a simplification, we're going to have x cubed divided by 3 minus 2 x to the 5th power plus our constant of integration c. And this is going to be our final, most simplified answer. Next, problem 3. Now, in this case, we have the integral of square root of x over 4. And the square root of x, that's a radical form, can be written in rational form as x to the 1/2 power. So let's go ahead and simplify this. And I'm just going to continue working below. What we're going to have is this over 4 is going to be 1/4. So I'm going to pull that 1/4 out front. And that's what happened here in rule number 3, where you have a constant, you can move it out in front of the integral symbol. That's what we're doing here. So we have 1/4. We have x to the 1/2 power dx. Okay, so let's go ahead below, equals 1/4, and now we're going to actually integrate. So we're going to have x to the 1/2 plus 1, which is going to be 3 over 2. And it's going to be plus c. And we're going to have to divide that by 3 over 2. And I'm just going to continue to work to the right. So dividing by 3 over 2 is the same as multiplying by 2 over 3. And when we have these fractional powers, this is a technique that we're going to be using often in integrating. So here we multiply instead by 2/3, and then we multiply by our fraction we had out front, which is 1/4, and we have x to the 3/2 plus c. And then we have in the numerator 2 times 1, which is 2, and in the denominator 3 times 4, which is 12. So that's going to give us 2/12. And 2/12 is equal to 1/6. So we're going to have 1/6 x to the 3/2 power plus c. And this can suffice as a final answer, but if we want to go ahead and rewrite this as we originally had in a radical form, it's going to be 1/6 square root of x. That's how we get that 1/2 to the 3rd power plus c, which is also a technically correct answer. So you'll find out in performing integrations, particularly with fractional exponents, that there's going to be, in many cases, a lot of simplification involved. The last one we're going to look at is this one, number 4, and we have the integral of x squared plus 3 over x squared dx. And what we have here is this x squared serves as a common denominator for the two terms in the numerator. So we can rewrite this as the integral of x squared over x squared dx. Okay, see what we did? We did that. Plus 3, because we have this 3. Well, it might be more visual. I'm going to say 3 over x squared dx. And continuing to the right, we have x squared over x squared canceled to equal 1. And so we have the integral of dx. And then this integral of 3 over x squared is going to be the integral of 3x to the negative 2 power dx. And then just rewriting this one more time, we have the integral of dx plus 3, moving that 3 to the outside, x to the negative 2 power dx. And now from here I'm going to work below, having run out of the room going to the right. So the integral of dx is going to be x, and then we have plus 3, and we're going to have x to the, what we do is we take negative 2 and add 1 to it and get negative 1, and we're going to divide by negative 1. And now, having finally integrated, we are going to introduce our constant of integration c. And so our final answer in most simplified form is going to be x plus, we have divided that 3x to the negative 1 power by negative 1. So that's going to give us minus 3 over x to the 1 power, x to the negative, yeah, x to the 1 power, and that's the same as x to the negative 1 plus c. And so this is going to serve as our final answer in our most simplified form. So we've covered really quite a few things that are going to be very helpful to you in your calculus career. And the simplification, I hope, was helpful. I hope this lesson was helpful to you. Good luck, and thanks for viewing.